Hello, today we are going to start a new topic called as Laplace transform of derivative of order n. So just let's have some recap what we have done in the last videos. We have started a topic called as Laplace transform. In that the Laplace transform is defined as f of s is equals to integral 0 to infinity e raised to minus st f of t dt. So these are the 7 important formulas which we have to by heart, you can say, for solving problems which are based on Laplace transform. So where L1 is equals to 1 upon S, L of E of AT is equals to 1 upon S minus A, L of T of N is equals to N factorial upon S of N plus 1, L of cos H AT is equals to S upon S square minus A square, L of sin AT is equals to A upon S square plus A square, L of sin H AT is equals to A upon S square minus A square, L of cos AT is equals to S upon S square plus A square. So we have solved these formulas here. So after that we have started a topic called as properties of Laplace transform. So we had two properties. This you can say it's a linear property where L f1 of t plus b L f2 of t, that is equals to, that is L of a f1 of t plus b f2 of t. Then shifting property theorem. So what does it say is that this L bracket e raised to st f of t is equals to f of s minus a, and based on these properties we have the few results which we should know. So first result was L of e of at raised to t of n, which is equals to n factorial upon s minus a raised to n plus 1. So this we are getting it as L of L bracket t of n is equals to n factorial upon s of n plus 1. Then second L of e of at cos h bt, which is equals to s minus a divided by s minus a whole square minus b square. Third one, L of e at sin h bt is equals to b upon s minus a whole square minus b square. And fourth one, you can see L of e of at sin bt is equals to b upon s minus a the whole square plus b square. So the difference between, if we'll add h here, it will be minus, and if there is no h, it will be plus. Similarly here also L of e raised to at cos bt is equals to s minus a upon s minus a the whole square plus b square. So if we'll compare the 2 and 5, same way the results are same, only the sign is different. Here it is minus, here it is plus. And also we have done Laplace transform of derivative, and which was f of t, Laplace transform of derivative of f of t. So that we have solved it here, and we have got the result till here. That is L f1 of t is equals to SL f of t minus f of 0. Okay. So now what I'll do, I'll mark this result as A. Okay. And as I said at the start of this video, we are going to start a new topic called as, it's just the same thing, just the derivatives, that order is n. Laplace transform of derivative of order n. So this equation we will be using here in this proof. So let me write the statement first. In L of fn of t is equals to Sn of L of f of t minus s of n minus 1 f of 0 minus s of n minus 2, it's f dash of 0 minus s of n minus 3 f double dash of 0 minus, it will go ahead, it will be f of n minus 1 0. Okay, so this thing we have to prove it here. So let's start our proof. So we know that L f dash of t is equals to SL of f of t minus f of 0. This, as I said, it's from equation number 1. Equation number A, this one, this thing we have written. Okay, so from 1, from A. Okay, and let me mark this one as equation number 1 for further solving. Now replacing f of t by f dash of t and f dash of t by f double dash of t in 1. So what we will get? So we are just replacing these contents. So L of f dash of t is equals to SL f dash of t minus f dash of 0. Let me mark this as equation number 2. Now putting the value of L of f dash of t from 1, this value I will put it here in this equations. In 2, we get L f double dash of t is equals to S bracket S L, one more bracket, f of t, closing this bracket, minus f of 0 minus f dash of 0. Okay, now what we are getting it here is sorry, L f double dash of t is equals to, so this comes out to be s square L f of t, okay, minus s f of 0 minus f dash of 0. Similarly, what we will be getting here is L f triple dash of t will give me s cube L of f of t, L f of t minus s square f of 0 minus s f dash of 0 minus f dash of 0. Also, one more step. Similarly, this was for triple dash. Now for 4 dash. Now L of, instead of writing 4 dash, f of 4 dash of t it will be equals to S4 L, it will be f of t minus s cube f of 0 minus s square f dash of 0 minus s of f double dash of 0 sorry minus f triple dash of 0. Also, thus what we are getting it here is L fn of t is equals to Sn of L of f of t minus Sn minus 1 of f of 0 minus Sn minus 2 f dash of 0 minus Sn minus 3 minus 3 and f double dash of 0 plus dot 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 minus of f of n minus 1 of 0. So that's it. So we have to prove this term and we have got the proof. So you can say directly here it's hence proved. So based on this Laplace transform, I'll do one problem. But before that, I'll just complete one simple definition that is known as the inverse Laplace transform. What is meant by inverse Laplace transform? If L f of t is equals to f of s, okay, then L inverse f of s is equals to f of t, where L inverse is called the Laplace transform operator. That's it. Okay, so we'll start one problem. Sorry. Find the Laplace transform of t sine hat. So L of sine hat is equals to a upon t sine hat. So first we will write the value of sine hat. So what is sine hat? It is a divided by s square minus a square. Also L of t sine hat is equals to minus d by ds of a upon a square minus a square. Why we are getting this term? This we are getting it since we are using a formula that is L of t of n, this is t of n, f of t, which is equals to minus 1 raised to n d by ds of n f of s, or what we are getting it here is L t sine h of at is equals to 2as upon a square minus a square. Hence, we have found the Laplace transform of t sine at. That's it. So you can see today we have started with the nth derivative for the Laplace transform. So how we should get the value for this was the Laplace transform. Previous it was Laplace transform of derivative of f of t. So So for that we are getting a solution like this. This is L f dash of t is equals to SL f of t is minus f of 0. Then the Laplace transform of derivative of order n. So for order n we are getting it this. And last not the least topic, we have this inverse Laplace transform. So what is inverse Laplace transform? This L inverse, we call it as a inverse Laplace transform, called as the Laplace transform operator. That is inverse Laplace transform operator. And we have done one proof. Okay. So that's it for today. Thanks for watching.